Have you ever wondered how tall Radio Tower really is? Well, of course, all you need is a rangefinder and there you go, 200 studs. You see, we don't use studs as a unit of measurement out in the real world. Instead, we have the glorious metric system, and America. Roblox themselves state that one Roblox stud is equal to 28 centimeters, so we can use this conversion for our measurements. However, there is another method available to us within AR2. You see, everything in this game is measured in studs. Distance, studs. Bullet velocity, and studs per second. The only units that do not use studs is vehicle speed, which uses miles per hour. Therefore, there is a possible in-game conversion between miles per hour and studs, and we can achieve it by driving a set distance at a constant speed. By using the snowmobile, which maxes out at exactly 50 miles per hour, it took 0.55 seconds to cross 28 studs. Since speed is the function of distance over time, we can get the distance by multiplying the speed by the time. First, converting the seconds it took into hours, then multiplying it together, and finally dividing it by 28, you get 1 stud equals 14.4 feet or 4.39 meters. Just a little bit bigger than expected. Well, it doesn't matter anyways because the devs confirmed that vehicle speeds is actually just studs per second, so we'll stick to the official Roblox conversion. So if I were to stand in front of Radio Tower and aim upwards with my rangefinder, it reads 188 studs, but obviously that's not the height of the tower, that's just how far I am from the top of the tower. Now, if you aim straight down with the rangefinder, you'll find two things. One, that range distance is measured from the eyes or the head of the player. The distance between them is very short and changes with face, so it doesn't matter, so we'll go with the head. And two, that players are only 4 studs tall, and 3 when crouching. Players are 3'8". For reference, here's the average height of a male at 5'9", and here's the player. Here's Shaquille O'Neal, and here's the player. Here's Peter Dinklage, and here's the player. You get the point, Short King. Back to the tower, we will need to measure both our distance from the top of the tower and our distance from the base of the tower to find the height. These measurement lines put together makes a scalene triangle, and to calculate side lengths of a scalene triangle you'd need an interior angle, which this game has nothing to measure angles with, besides the compass, but that measures on the x-axis so it's useless. We will have to use our player's height of 4 studs to make a second right angle triangle to determine the perpendicular distance from us to the base of the tower. And with that we have 2 side lengths and a nice right angle triangle. And finally, we use Pythagoras' theorem to determine the height of Radio Tower. Putting in the numbers gives us 181.8 studs, which is 50.9 meters tall. That's about 46 M60s tall. And if we use the rough in-game conversion, we get 799 meters. That makes Radio Tower only slightly shorter than the tallest building in the world, and our characters climb it in less than 20 seconds. Now how about the best place to get snapped from? Grain. My distance is 31 studs from the base of the building, and my distance is 111 studs from the top of the building. This is the same process as last time for determining height. 2 triangles, Pythagoras' theorem. This gives us 29.86 meters tall, around the average male height if the average male height was 30 meters. Now we know the scale of these 2 famous buildings, but how about structures that aren't tall? How about we measure in length? Before I jumped to using the rangefinder, I tested with a snowmobile how long it would take to go in a straight line from one side of a grid square to the other. Now I'll be treating in-game vehicle speed as studs per second instead of miles per hour to measure, and it took 51.6 seconds at 50 studs per second to cross a grid square. Multiplying them together gives us 2,580 studs, or 722.4 meters, meaning the AR2 archipelago is only 4.3 kilometers long and 3.6 kilometers wide. In area, that's only 15.5 square kilometers, roughly the same size as Ashland, Virginia. Okay, while I was editing this, I was having a conversation with Spencer about figuring out where the AR2 alpha map could take place, and he gave me the idea of scaling up the size of the map to the size of people instead of AR2 characters. So the average male height is 175 centimeters, and the AR2 character's height is 112 centimeters. So 175 over 112 is 1.56. Therefore, the map needs to be 1.56 times bigger to scale for human size, and we get 24.24 square kilometers scaled up. Just wanted to throw that in. Now back to the video. Speaking of Ashland, how long really is Ashland Bridge? Now we use the rangefinder and it's a similar process to determining height. You measure the distance from your head to the other end, just that you only need to measure once because your player acts as the height of the right angle triangle. Now we have 2 side lengths, so we can use Pythagoras again and we get 846.99 studs, so basically 847 studs, or 237.15 meters. Lastly, we are going to measure the area of volcano. Kind of. This took a lot of time to properly calculate, and I don't even think it's really accurate due to a lot of small factors like the area not being actually flat. To properly measure a flat area, surprisingly, the area has to be flat. So I have found 4 points roughly even in elevation across Volcano, which is Santa's workshop at the time of recording, and I measured the distance between every single individual point, and here's what I got. We start with point A, to the right of this little lookout spot north of the caldera, then to point B, the southwest corner of this little cage tower northeast of the caldera, then to point C, the end of these little road barriers on the northernmost point of labs east of the caldera, then finally to point D, the western side of the roof beam on the bridge that's only here during the Christmas event south of the caldera. These are the values from each points that I had measured, and this is the shape that these points make when joined. So let's begin. Now, from using the rangefinder, we have the lengths of all sides, and now we can divide this irregular shape into triangles, and from there, determine the area of each triangle and add them together to have our result. I measured the length of the dividing line between point A and point C to 1064 studs, and now we have these two scaling triangles. We would need to split them further into right angle triangles, but we don't actually know the point of intersection between these two lines, and therefore we don't know the height of either triangles. Instead, we're going to have to use Heron's formula. We add the three sides together to get the perimeter and halve it. We now call this the semi-perimeter, or S. And in Heron's formula, you get the square root of S multiplied by S minus each of the sides to get the area. Plugging our numbers in, and we get 437,739 square studs for the south triangle and 163,138 square studs for the north triangle. Adding them together, and finally we get 600,877 square studs, or 47,109 square meters, which is the average size of a shopping center. Anyways, this hurt my brain. Thank you for watching. See you.